In this video, we're going to look at the binary shift concept and how this can be applied to the GCSE questions you might get in the paper. So the first thing to know is, what is a binary shift? So a binary shift is when the numbers are shifted either left or right to either multiply or divide. So the way to think about it is that imagine an arrow like this going left and right. So if we shift a number to the left, we multiply it. If we shift this to the right, so it's a really bad multiply, we divide, okay? So it all depends which way you're going, really. And normally the questions will tell you which way to shift this as well. So as you can see here, this question says shifting 2 places to the left. So we know that we are multiplying that number. Or if it says to the right, you know that number is divided, okay? There is a more complex way about multiplying binary numbers, but you don't need to worry about that at GCSE. So there's 2 types of questions you might get, really. One question, as you can see here, is basically giving you a binary number and asking you to physically shift it left or right, which is relatively straightforward. The other example is explaining how a binary number can be shifted, and there's a rule to that as well. So let's start with the first question, because in my opinion, this is the easier type of question. So what you're given is a binary number here, 0011, 1001. And it asks you to shift this binary number 2 places to the left. So that's nice and straightforward. All you need to do is physically move this value to the left, and any zeros or ones that kind of go off when you shift left, they just disappear, and then you add some leading zeros to the right, okay? So if we have, let me just draw it out over here. So if we have 0, 0, 1, 1, 1, 0, 0, 1, and we shift it 2 places to the left, you've got to imagine that we shift it like this, so it becomes 0, 0, 1, 1, 1, 0, 0, 1, and then we have some leading zeros at the end. So what happens is basically that number shifts to there, that number shifts to there, and that number shifts to there, and so on, okay? And obviously these numbers are removed because they don't fit in the 8 bits that we have, so your answer is this here. So the answer becomes 1, 1, 1, 0, 0, 1, 0, 0. So all we've done is remove the zeros from the left, which are here, and added some leading zeros on the end. If it asks me to do 2 places to the right, we'd simply move these 2 numbers at the end. So with this 0 and these numbers would move down, and then we'd just get 2 zeros on the left. So that's nice and easy. You just shifted numbers left and right. The second question, explain how a binary number can be multiplied by 8 by shifting bits, okay? So to answer this question, you need to understand how binary shift actually works. And if you're multiplying, we use the method of 2 to the power of, okay? So if I did 2 to the power of 1, so if I was shifting it by 1 position to the left, to the power of 1, I'd actually be shifting it 2 places, so we're multiplying by 2, okay? So one shift to the left. It's a really bad 2 there, I apologise. I'm just gonna redraw that 2 again, bear with me. So 2 to the power of 1 equals 2, okay? If I was to move it 2 places, 2 to the power of 2, I'm actually multiplying the binary number by 4. If I'm shifting the number by 3 places, I'm actually multiplying it by 8. If I'm shifting it 4 places, I'm multiplying it by 16, and so on. You get how this works, okay? It's always 2 to the power of. So this question is asking, what is the result of shifting, multiplying by 8? So what that means, nice and straightforward, is the number is shifted 3 places to the left. Because if you look here, we can see that 2 to the power of 3 multiplies the binary number by 8. So therefore, if I am shifting it 3 places to the left, then I am therefore multiplying it by 8. If the question said can be multiplied by 4, then it would be 2 to the power of 2. So the answer would be the number is shifted 2 places to the left, and so on, okay? So that's how you do binary shift.